Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and today we are completing our study of equations of straight lines, part 4 of our video series. Let's get to it, shall we? We're going to imagine some dragons along the way. We're talking perpendicular bisectors. Okay, what is a perpendicular bisector? Well, let's take a look here. Get rid of that little faux pas. If you take a look at this line segment right here, okay, its midpoint is M. The perpendicular, no. We're going to take a look at this line segment AB. So sorry. Line segment AB, yes. And this line right here, this line segment, is the perpendicular bisector of line segment AB. And that is because it cuts the line at its midpoint. And these little marks right here indicate that AM is equivalent to MB. Those links are the same. So that makes M the midpoint. And it is perpendicular, this line is perpendicular to that segment. Okay, that makes it the perpendicular bisector. Now, any line that goes through the midpoint is a bisector, but a perpendicular bisector forms a 90 degree angle with the segment or line that it is bisecting. Okay, and any point like la 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 la, boom. Let's say I pick any point is equidistant from the endpoints of the line segment. And I should say any point on the perpendicular bisector. What that means is the distance, these distances, let me go ahead and label this. I'll label this point C. The distance from C to A is the same as from C to B. And again, it doesn't matter. Let's say I put one way up here. The distance, here I'll label that too. The distance from A to D is the same as the distance from D to B. They're not normally the same. I shouldn't say they're not normally the same. They're not always the same distance. In other words, I could have another point, I don't know, closer here. And while these distances, like from here to here and from here to here, if I call that point right there point E, A to E is the same as E to B, but A to E does not equal A to C. The main thing is they're equidistant, the same distance from the endpoints. All right, so let's take a look at this. Find the equation of the perpendicular bisector of AB for A equal to -1, 2, and B, 3, 4. So the perpendicular bisector is a line. Okay, so we are finding the equation of a line. So we need the gradient of that line, and we also need a point on that line. And if it's going to be the perpendicular bisector, we need the midpoint of the line segment. So midpoint of AB. And I'm just going to show you what that looks like. I made the graph already, and it gives away the equation of the line, but we have to find that equation algebraically. So here's point A at -1, 2. I plotted that -1, 2. And then point B at 3, 4. 1, 2, 3, 1, 2, 3, 4. So you can see that. And then I found the midpoint of line segment AB, which occurs at 1, 3. And so then I found, or I graphed the equation of the line that is the perpendicular bisector, and it turned out to be -2x plus 5. And we're going to find that here in just a second. And you see it goes right through the midpoint. This line, when graphed, goes right through the midpoint and forms a 90-degree angle with the line segment. So the line forms a 90-degree angle with the line segment. All right, so let's take care of the slope first, slope or gradient. So first I'm going to find the slope of AB. And I have these 2 points, so that's going to be my change in y, 4 minus 2. over my change in x. 3 minus a negative 1. And that equals 2 over minus minus plus is 4. So that equals 1/2. Now I need you to recall, I should say slope of AB here just so we don't get confused. Recall lines that are perpendicular have gradients or slopes. I'll say gradients and slopes that are perpendicular. That are not perpendicular, that are opposite reciprocals. Okay, so the slope of AB is 1/2. Okay, so that means the slope of the perpendicular bisector must be equal to the negative reciprocal of 1/2, which is -2 over 1, or we'll just call it -2. So it has to go through the midpoint if it's going to be the perpendicular bisector. So I have to find the midpoint of AB. And remember, that's just the average of the x coordinates, -1 plus 3 divided by 2. And then the average of the y coordinate, 2 plus 4 divided by 2. And that ends up becoming -1 plus 3 is +2. 2 over 2 is 1. 2 plus 4 is 6. 6 divided by 2 is 3. So my midpoint is 1, 3. And if we look over here, we verify that. Okay. So now the equation of the line. The slope is -2. And I know that a point it goes through is 1, 3. So I'm going to go ahead and go with y equals mx plus b form. Okay. And I know my slope is -2. Right? So I have y equals -2x plus b. So now I need to find b, and I can do that if I know a point on the line, which I do right here. So I'm going to substitute 1 in for x and 3 in for y. So that means that 3, again replacing y with 3, which is right here, is equal to -2 times the x coordinate 1 plus b. So 3 equals -2 plus b. And if I add 2 to both sides, I get b equal to 5, which means I take this, where I already have the slope, and replace b with 5, and I get y equals -2x plus 5. And lo and behold, there we go. It's verified because I had the calculator software do the perpendicular bisector. We have found it, showed you graphically, showed you algebraically, and that's all I have. We'll talk more in class. Hope you enjoyed it. I enjoyed it. Let's get some more Imagine Dragons because I am out.